Tonight's session that we're going to enjoy is Acoustics Made Easy. Now, the background of this is if you cannot hear or understand announcements made at airports, churches, shopping malls, and even your television at home, chances are it's not the sound source but the room acoustics that need help. Primacoustic of British Columbia, Canada, incorporates the radial engineering approach to acoustic design and treatment. Both Radial and Primacoustic are well experienced in room acoustic modelling tools, products and manufacture for absorptive, diffusive and reflective room treatments, including bass traps. Primacoustic is represented in Australia by Amber Technologies. As an extended member of the Primacoustic team, Matt Harder of Amber here in Australia will take us through the challenges and triumphs of room acoustic treatment. Now, a bit about Matt. Matt is the professional products brand manager at Amber, and he's handling such well-known product lines as Canair, NTI Audio, Von Dom, Neutrik, Reen, and of course Primacoustic. And there's quite a bit of business in Australia with that lot. Matt has had extensive experience with both technical servicing and with management, today being responsible for Australia-wide product and technical support. Matt has said to me that he'd like to field questions if we can manage that through your facilities you've got for chat, and so we can capture your questions and then we can ask them the appropriate times, or if Matt, if you want to take questions, just let us know. So what I want you to do is to make Matt welcome to AES Melbourne for his presentation, and I trust you'll enjoy it. So you can unmute and give him a round of applause and then mute. Over to you, Matt.
Thank you, Graham. Hello, everyone. Thank you for the invitation, the opportunity to present tonight. I'm going to be sharing with you some ideas and solutions for acoustic treatment of rooms using off-the-shelf products along with some free planning tools available from Primacoustic. Just a little bit about the history of Primacoustic and its parent company, Radial Engineering. So, as Graham mentioned, Radial Engineering is based in Canada, just outside of Vancouver. It was founded by Peter Janis, and the company was started actually with the purchase of a cable company called Cable Tech in around 1992, and eventually that company became Radial Engineering. And the first product that Peter launched under the brand of Radial was the Radial JDI Direct Box, which was in 1996. This was a passive direct box, and that was quickly followed up with the active version, the JDB, in 1997. And today the product range spans a range of direct boxes, splitters, audio interfaces. Essentially, it's a lot of problem solvers that are used on stages and studios all around the world. So Primacoustic came into the fold in the year 2000. It's the first sister company that Radial put together. And originally, the product was a foam-based product, and eventually they realized that they could get better performance from a glass full product. And so that they transitioned to that for their entire range, and that's the product that they're still using today. Some time ago, they came up with something called a London Room Kit, and this was developed to simplify the acoustic solution for a small to medium studio or home theatre system, that kind of listening environment. The idea was that you could get one package and everything that you needed was in this package. You had all the mounting hardware, you had a basic plan for how to lay it out in the room, and a few simple tools to position the panels correctly. So tonight, we'll go over some of the rooms that can benefit from acoustic treatment, when you might need an acoustic engineer, and we'll go over the basics of sound absorption, and I'll also give a little demonstration of using the Primacoustic Room Calculator and the newly released Room Designer. So I'll just share my screen here. So basically what drives the market? We've got noise pollution, safety issues, communication, particular call centres and teleconference, intelligibility, such as airports, shopping centres and schools, there's certain situations where you need to be able to hear an announcement, particularly if there's an evacuation or something like that is required. We also have comfort issues with ear fatigue in restaurants and in schools as well. Enjoyment for cinema, music, and working in recording studios, which can also be a hobby as well, and film and broadcast. So any room can benefit from acoustic treatment. We can see a few examples here. We have House of Worship. You can see the panels that have been installed on the wall here. And this is a more modern church that has a band. More traditional church that would use a pipe organ. We have community halls. These can be a little bit challenging because they're multi-purpose rooms. They could be used for anything from sport to community meetings to a concert or anything like that. So those rooms can present a particular challenge. And we also have live theatre applications, lecture halls, gymnasiums, fitness rooms, restaurants and cafeterias. This is an interesting one here. It's actually a cafe in Russia, and you can see there that they've actually painted over the panels and incorporated it into the artwork on the wall. And retail shop application, where you can see they've put acoustic treatment in the room where you'll be playing your guitar to test it out. Doggy daycare was an interesting one, where actually when you've got a lot of dogs in a room and that one starts barking and they all start barking, if you put acoustic treatment in the room, it can actually help calm them down a bit. Conference centres, boardrooms. I think we've all had that experience where we've been on a video conference for somebody and you haven't been able to understand the person at the other end. And a lot of that is because of the amount of reverberation that's in the room. Libraries, and of course recording studios, and home theatre systems as well. So, very important topic, when are acoustic engineers required? Soundproofing is one of those issues where you would need an acoustic engineer. And the reason for this is because acoustic panels won't actually stop sound moving from one space to another. This is more of an isolation issue, so you need to actually do something to the building itself to isolate the two spaces. Mission critical listening environments. Now this could be a high-end recording studio, it could be the control room for emergency services, it could be a broadcast studio, anything like that where you have a mission critical listening environment, you probably should be engaging an acoustic engineer. The design and build of a theatre or a church, new construction, this is really important because if you engage an acoustic engineer right at the beginning in the design stage, the money that they charge you will easily be paid back in not having to pay for acoustic treatment later. And also to solve major vibrational isolation problems, and also when budgets allow. So if you take, for example, say, for example, the Sydney Opera House, they've obviously got a very large budget. The concert hall, as some of you probably know, is being redone for the acoustics. And of course, you would engage acoustic engineers in that situation. At the other end of the scale, if you're doing a small home studio, you probably don't have the budget for that. And then in between, it would be up to you to decide, based on your budget, what your expected outcomes are, your experience and so on, as to whether or not you engage with an engineer. If you decide that you do want to engage one, you can find your nearest one at the Association of Australian Acoustic Consultants. The web address is there, and I think you can probably put that in the notes at the end of the meeting. Just a few acoustic myths. One would be that you need to be an acoustician to hang panels on the wall. That's not necessarily true. You can still make a good improvement to a room without having to be an acoustic engineer. Rooms need computerized analysis in order to be improved. Yes, computerized analysis is going to help you if you have access to it, but you still can do a good job just following some simple rules. Voodoo and witchcraft and electronic processing. Electronic processing is good to a point, but it does have its limits, as you probably have discovered when you are doing video conferencing. And what can you do? We can control the sound with absorption. So absorption solves the majority of room problems. It controls the reverberant field, reduce distractions, solve most intelligibility problems, and create a warmer, more comfortable room. If you think of an empty living room and how it sounded, and then how it changed when it became full of furniture. So this next section, we're going to go through sound absorption, how much you should use, where does it go, how thick does it need to be, how do you put it up, other tools that you can use, and if there's any other concerns that you might have. Now, I might just stop at the end of each of these sections and see if anyone has any questions. So how much do you use? If you just place one panel in a room, not much is going to happen to the sound in that room. If you place a lot of panels in the walls, then you're going to make a big improvement. So there is a relationship between the amount of acoustic treatment you use in the room versus the effect that it has. Where do you place the sound absorption? Common sense, use tricks of the trade, corners, parallel walls, the mirror trick, which we'll go through later, and decoupling and vibration. So if we look here where we have the singer, a microphone, and a wall behind the microphone, the red line indicates the sound waves that are coming from the voice. The green wave is representing the sound as it reflects off the wall. And as you can see, it's out of phase with the original signal, and this is going to create a problem when you're trying to do the recording. We can take this a step further, and we have a venue with a PA system that has two speakers. You can see there, in this particular case, we're just going to look at one listening position, which is the blue highlighted seat. It gets the direct sound first, arriving at the listener. And then there's a reflection. And you can see that in this listening position, the first reflection is almost as loud as the direct, but also that the phase is almost okay. But if you move just one seat away, you could get phase cancellation because of the distance between the listening position and the reflection and the distance from the speaker. If you add in the other speaker on the other side of the room, you end up with a complex mixture of direct and reflected sounds. And you can see that if you change between the two positions, you can end up with two completely different results. So depending on where you sit in the room, you may end up with the sound being okay or not being okay. So the primary reflections, you get the direct sound from the loudspeakers, the primary reflection from the wall, and then you get peaks and valleys called room modes, which are created. These room modes, they're directly related to the dimensions of the room. So if in this example here, you can see a room where the wave is going from one side to the other, but actually the sound wave actually fits into that space in the room, and it's directly related to the speed of sound divided by the length of the room, and that gives you the wavelength. And when the sound, the direct sound from the speakers, is out of phase with the resonance in the room, that's when you end up with a null. But when it's in phase, you end up with the sound combining. So you can move around the room and you'll end up with some spots where that particular frequency is louder and softer in other areas. And you get the same thing between the front and the rear walls, and from side to side, and also from the roof to the ceiling. Another problem you get in the room is the flutter echo. And there's from the ceiling to the floor as well. So the solution is to absorb the primary reflections. An acoustic panel strategically placed in the room, the amplitude of the reflected sound is attenuated, the peaks and valleys are reduced. So you can see here in this particular situation, if we go back to the original spot in the blue, you can see that the energy from the reflected signal has been reduced. And if we move, there's a missing slide, I'm sorry about that. But if you move to the other position, you end up with those waves being reduced as well. Now, just on this, we mentioned earlier the mirror trick. So this is a thing where you can actually put a mirror along the side of the wall. And as you move it along the wall, when you see the speaker, that's where a good place to have a speaker is. Now, obviously, the bigger the room, the harder that is to do. But if you're doing, say, for example, a home theatre system or like a home recording studio, it's much easier to do that. And you can see here that they've placed the panels strategically around the room so that they absorb those first reflections. So how thick, I should just ask if anyone has any questions there.
Hello.
Yes.
With the percentage of room coverage for effect, you showed that graph. Do you have a recommendation for the percentage of room surface to be treated, and do you include the floor area in that?
Yes, so what Primacoustic has for all of the various different types of rooms, they've recommended an amount. So, for example, in a boardroom situation, they would recommend between 20 and 30%. In a recording studio, they're recommending around about 30%. And they're making this calculation based on the wall surface area. And that doesn't necessarily mean that all the acoustic treatment has to go on the wall. Some of it can go on the ceiling, but it's just a method of them calculating how much treatment to install in the room.
Thank you.
Okay, so how thick does the treatment need to be? So if you look at the frequencies that are being generated by a three-way loudspeaker, you have your tweeter with the high frequencies, the mid-range, and the woofer. And basically, the more energy that the sound wave has and the longer the sound wave, the thicker the panel needs to be. So if we look at the panels that Primacoustic produces, this is their 1-inch panel, and you can see the effective range for this one. So the measurements are done up to 5 kilohertz in the lab, and you can see there that it starts to drop off around about 600 hertz there and drop off, and that's with a 1-inch panel. With the 2-inch panel, you can see that the effective frequency range extends further into the lower frequencies. And so we can get right down to 250 hertz before it really starts to drop off. And then with their 3-inch panels, we're getting down to around about 125 hertz before it starts to drop off. So as you can see, there's a direct correlation between the thickness of the panel and in particular the lower frequencies that it's effective at. So how do we put up these panels? They use some pretty scarily named hardware. Those things across the top there are called impalers. You might be able to see that they're quite sharp. So it's probably a bit difficult to explain without having one in your hand, but essentially the panel is made of a fiberglass wool, and it's been hardened with a resin. So it's a bit like a honeycomb. And so essentially you screw these pieces of hardware into the wall, and then you impale a panel on the hardware there. They also have some other tools that you use there for suspending the panels. So we can look at some other tools that we can use as well. In terms of controlling bass, I know this is of particular interest to Graham. we're going to increase the airspace behind the panel, and you can see there that it has quite an effect on the lower mid frequencies. And the reason for this is because the sound wave is going through the panel, reflecting off the wall, and then coming back through the panel again. So you get an improved performance in that sort of lower mid frequency range. Extending on from that, we have the tri-corner panel, which goes up in the top corners of the room. And that creates an air gap behind the panel in a similar way to the offset there. And then this graphic, it's the best one I could find. I'm sorry that it's not clearer, but it's what they call their London bass trap. And that's essentially a standard panel that's been mounted in the corner, and it creates an extra air gap behind that so that you get that extra effect. And that extends the effective frequency range down to around about 100 hertz. And then finally, they've got what they call their max trap and full trap. The construction of these is basically the same. The only difference is that the max trap is designed to be mounted in the corner, and the full trap can be mounted flush against the wall. How these are constructed, essentially they act in three ways. The first is that you have the 3-inch panel, which absorbs frequencies down to 125 hertz. Mounting them in the corner increases the performance of that panel down to around about 100 hertz. And then the real trick that they have here is their diaphragmatic resonator, and that provides the performance below 100 hertz. Essentially what this does is it resonates at the frequency with the highest energy in the room. It behaves like a large microphone diaphragm, and you end up with a thermodynamic transfer. So you end up with essentially the noise vibrates the resonator, and then it dissipates it so that it's no longer bouncing around the room. The full trap, the one that mounts flush to the wall, works in exactly the same way, but of course it's missing the corner mounting, so it's not mounted in the corner, so it's only working in those two ways. Another product that they have is Diffusion. Now with Diffusion, a lot of people like Diffusion because it doesn't make the room sound as dead, and instead of absorbing all of the sound, it breaks it up into smaller parts and scatters it around the room. So this can give you a sense of space in the room. It can make small rooms sound bigger. A lot of hi-fi enthusiasts prefer diffusers over absorption. And it can also help eliminate the flutter echo, because instead of the sound bouncing directly backwards and forwards between each of the walls, it's scattering around the rear of the room. And this is a very basic diffuser, which is essentially just a grid made up of a wooden frame. And then they have their flexible fuser. And so this is a combination of absorption and diffusion. So you can move those slats around so that you can change the amount of diffusion versus the amount of absorption that's in there. So there's actually a panel at the rear of the case there. And then this is the Razorblade Quadratic diffuser. Essentially what that does is it's got a bunch of wells in there that are all at various different lengths. So the sound goes in there, and it's because of the distance that it is from the wall, it changes the timing of the reflections for each of the various different frequencies. And this is sometimes called the Schroeder quadratic residue diffuser. And I'd like to stop there, see if anyone has any questions.
Yes, Matt, we've got a couple. Rod, are you there, Rod? He's unmuting. Yes, Rod was asked.
Yes, I'm there.
I can ask you a question, but thank you for being there. The fiberglass panels, Rod was interested in what approach you adopt to stopping glass fibers entering the space.
Yeah, so there's two mechanisms there. One is that the fibers are actually hardened with a resin, so they're not floating. in the same way that you might find, say, in a bat that you put in the ceiling. So there's that mechanism, and then it's also encapsulated in a fine mesh that holds any fibers that happen to become stray. They're held within the mesh, so they can't get out. And then there's also the fabric covering that goes over the top of the panel.
Thank you.
Okay, and then Nick Harrison. Is Nick there? Yes, Nick's there.
Yeah. Yeah, I've just got some of the Primacoustic panels, and I don't have a place on the wall to actually chuck them, so I'm sort of suspending them from the roof. And like, just out of interest, I guess whether there'd be a low frequency benefit to that. You know, say they're around 2 meters away from all of the walls. It's not too important. I just for interest.
You can get some. You can get some small improvement in the bass performance of them by suspending them.
Okay.
By changing the length. So have you got them flush to the ceiling, have you?
Yeah, just vertically.
Yeah. So yeah, if you suspend them, say maybe have a 30 mil to 60 mil gap or something like that, then you can improve the bass performance of them. But it's going to be marginal. It'll be similar to using the offset impaler. So the standard Broadway panel goes down to about 125 hertz, and by adding that air gap, you're really getting it down to about 100 hertz. So there's a small improvement, but not a huge amount.
Okay, this kind of isn't with an air gap. This is just literally suspended, kind of in the center of the room.
Like a baffle. Yeah.
Yeah.
Yeah. So if you wanted to help the bass there, it'd be better if they were mounted horizontally.
Okay. Right. Yeah. Get them. Yeah. Okay.
But, Matt, the other point would be that the vertical mounting, if they're double-sided panels, you've doubled your surface area with the panels if you're hanging them vertically.
Also, the length of them has an effect. So the longer they are, or the further they are from the ceiling, that can further affect low frequency. It's a floating baffle type absorber.
Yep.
Good question. Thanks, Nick.
No worries.
Yeah, actually, it's a good point, Nick, as well, is sometimes you can get a situation where if you put acoustic treatment up in the room and you don't address the bass issues, you can actually make them seem worse because you've put treatment in there that's addressing those mid and high frequencies. And so the reverberation of those has come down, but it hasn't for the bass. So therefore, you're presented with a situation where the room sounds boomy or has too much bass.
Yeah, that's a good thought. Thanks, Matt.
That's right. So just going to quickly compare the difference between the glass wool and the urethane foam. And this is a particular interest to Primacoustic because they originally started out using foam, and they discovered that the glass fiber just works so much better for them. And one of the reasons for that is because foam contains a lot of air. It's not very dense. So what ends up happening is it's very good at absorbing high frequencies, but not so good at the mid to low frequencies. By making the panel more dense, you end up being able to absorb those lower frequencies more because there's more rigidity to the panel, and therefore it can vibrate at those lower frequencies and transfer that energy from acoustic energy into heat energy. So but that's the basic reason why they changed to this product, because they just feel that it's a much more improved performance, and it's a more even frequency response the way they've picked their design of the panel. And you can see there the comparison between them. Another important point is fire safety. So urethane foam, I think there's, in the last couple of years since these slides were written, there's probably been a few advancements in the fire safety of foam. So I wouldn't say that they're all unsafe, but a good percentage of the foam product out there would not be fire safe. Whereas the glass panel is a class 1 fire safe product. The other thing with foam products is typically they're glued to the wall. The Broadway panels, they're using those impalers which you screw to the wall. If you've ever tried to remove foam from the wall, it's a really long, difficult job. Whereas if you have to remove the Primacoustic product from the wall, you're really just filling in holes like you would if you pulled a picture book or something like that. So just quickly go through the range of panels. Essentially, they're all the same product, but they're just various different shapes and thicknesses depending on the situation that you need. So we have scatter blocks, we have control columns, control cubes, broadband panels, and they also have some different shapes if you need something more aesthetic. The London Room Kit, this is something that we mentioned before, and these are the kits that Primacoustic originally came up with to make acoustics simple. So essentially you could take home this kit in a box. It's got everything you need. It's got the mounting hardware, and you, going off their website, you can see the basic way that you should set it up so that it works correctly. So here we have the London 8 room kit. This is their smallest one. So it's really a very simple kit. It's for very small rooms. It's just got a couple of control columns and some scatter blocks. It doesn't do a huge amount, but it's enough to control the reverberation in the room and give some improvement. And it's a nice little starter kit. If you don't have a huge budget to start off with, you can add more panels to it later. London 10 kit is that's their next level up. You've got a lot more control columns there, and the control columns are larger, and you have a larger scatter block arrangement there. And this really addresses the issues with the Flutter echo and starts to address some of the room modes in the upper mid frequencies. And also, of course, the first reflections that are coming off your speaker position, and also the energy that's around the speaker in the low frequencies reflecting off the back there. So that's why there's some panels at the back of or at the front wall where the window is there. And then the London 12 kit is essentially the same as the London 10, but they've added the London bass traps to it. Now, the London bass trap, as we mentioned earlier, this is essentially the standard panel that's mounted in the corner, and it's providing the air gap behind it to give that extra performance in the bass end. And then the London 16, again, it's just a larger room kit for a larger room. And recently, they've also created a clarity room kit, which is for boardroom situation. It's a little bit different from their previous kits in that really it's just two different panels that you can arrange however you wish, so that it looks good around the room. They're white, and you can paint them or you can print on them. So this is a particular interest in a corporate situation where someone might like to put logos or corporate colours, etc. on there. And that leads us into the paintable panels, where you can see here that the panels have been painted, various different colours. In this case, it's been painted the same colour as the wall. And in this case, it's actually been printed on. So just to explain with the printing process, it's just an inkjet printer on a flatbed. And most professional printers will be able to print on these, provided that they can accept the thickness of the panel. And with the painting, the paint has to be a very fine spray paint. If you roll the paint on, you'll affect the high frequency performance, and I've just got a little graph here showing that. So you can see the absorption coefficient there across the frequency spectrum, and the blue line is the original, and then you have the light spray of paint. On the green line, you can see it's almost the same. Then you have the orange line there, which is where someone's rolled the paint on. So you can see there that unless you wanted to reduce the performance in the high frequency for some reason, you would not roll the paint on. And they're the 3 different shapes that the paintable panels come on. The paintable panels can be of particular interest for anyone where they don't want black, beige or grey looking panels, so you can get almost the same performance as a fabric covered panel, but you get that aesthetic look to them. And these are just some of the examples where paint has been applied or printing has been applied to the panels. And then we have sealing treatment, which has come up before. So this particular type of sealing treatment, it's the same as our wall panel, but it has a frame on it. And that frame allows you to connect all of those panels together to make up a larger panel that you would put over the mixed position in your studio. And by having that frame design, you can add more panels to it to create a bigger panel if you need to. They also have the Nimbus cloud, which is essentially the Stratus without the frame, and you suspend those. And these are particularly useful in environments like an open plan office or in a restaurant. And then they've also got their cloud paintable ceiling as well. So that's this one's showing the hexagon shape. They've also got square and circular shapes as well. And these are their baffles, which I think the question before might have been using. And these are particularly useful in areas where you have a very large room and a high ceiling, such as an airport. And these help to control all of that background noise that's going on and all the reverberation that goes with it. And typically you would mount these in random positions up high in the ceiling. And then you also have what they call a thunder tile. So this essentially replaces the panels that you would find in a drop ceiling or a T-bar ceiling, I think they call it. And then finally, they have a new product called the Telewall. And this essentially allows you to create the panel that covers the entire wall. And you use this track system. So you can see there that you create the shape that you want, you put your raw panels in, cut to size. They don't have any covering on them because you then put the fabric over the top of it yourself that you would like. So that brings to an end that part of the presentation. I'll just see if anyone has any questions before we move on to the room calculator.
Any questions?
Yes, if no one else has got a question. I noticed, Matt, on the slide where you're talking about the differences between paint applied by spray and the roller and the graph there, that the spray painted surface actually has more absorption at a lot of frequencies, a lot of the range, than does the raw panel. So some people might see that as an advantage, but is there a particular profile that Primacoustic is after that they haven't created that higher absorption by painting all panels?
Let me just go back to that slide. From memory, I believe that the performance is probably enhanced in the lower frequencies.
I think, yes.
Yeah. So essentially, because you've hardened the outside of it, that's why the lower frequencies have improved a little bit there.
But I'm just wondering, some people would be after that extra performance. So it just seems strange to me that I was expecting that the painting would be something that would be seen as a disadvantage, and because it reduced the performance, but here it's actually improving the performance at the lower end. So some people would be advised to get their panel painted even if it's the right colour to begin with.
Yeah.
And even a bit up at higher frequencies around 1K as well. It's smooth.
Yeah, it has done it a little bit there as well. I guess they're probably not advising that because I think the target market for the paintable is probably not for high performance music. I'd say it's more in the area of boardrooms, perhaps some home theatre systems, that kind of thing.
Also, Matt, I wonder how repeatable that would be, that performance.
In terms
of taking it to your local spray shop to get done, sort of one practitioner versus another, and their techniques may give varying results.
Yeah, I can ask Primacoustic how many tests they did for this to see.
Maybe that's an average.
What the results were. So yeah, I would say that this would have been an average from a number of tests.
If you apply enough paint, it'll end up being the absorptive properties of a Renoir or a Picasso.
Yeah, that yellow line. Also, Matt, you're talking about ceiling tiles, and I've run into this with architectural lighting fixtures. North American products are made for a 1 foot tile grid.
Yes.
And our tile grid is just minimally smaller at 30 centimetres or multiples thereof. Yep. So I wasn't sure from what you're saying right towards the end there, can you trim those tiles to fit in, or is it an impossibility?
You don't need to, because recently they've made available the European sized.
Metric sizes, right.
Yeah.
Fantastic.
So that's it's only for the Thunder tile. I think they've got another product called the Stratus tile, which is a lighter version of it, but they haven't made the European version for that. I don't know why they haven't. We can ask them to make it.
Yep. Okay, thank you. Well, at least they're being proactive on that part. Some North American companies just don't recognise that there's a world outside and don't think about it.
Yeah. So is there any other questions before we go on to the... With that, you'd be looking at where are the sound sources coming from and where the reflection points are compared to the listening position. That would be the first point of reference, and then you're also going to address other issues with the Flutter echo by where you place those panels. I actually go into that a little bit in the Room Designer. I'll just quickly show you this spreadsheet. This is their room calculator, and it's not meant to be 100% guide as to what to do. It's just to give you a ballpark of the amount of acoustic treatment that should be used in a particular application. So you can see here all of the cells that are highlighted yellow are where you can input data. And for this example we're going to use today in the Room Designer, I'm going to use a room that's 4 meters by 6 meters and with a 2.44 meter high ceiling. And it's worked out there that the total square meters of the wall surface area is 49 square meters. And from that, you can see there that they've got the percentages of the various different types of coverage. And so if we're doing a recording studio, for instance, we might aim for 30%. And in that case, you would need 15 square meters of treatment. In a boardroom situation, you could probably do 10 square meters. So as you add product to the sheet, you'll see that it changes. So the amount of used coverage and tells you how much extra you need to apply. So if we put in here a London 16 kit, for example, we'll get around about 20% performance, and this would be a good place for you to start with your studio, and you can then add more panels to it later or straight away if you want as well. So we could add some ceiling treatment there. So if we add, say, 3 Stratus to put across the listening position, and we might want to put some bass traps in. So we might put 3 max traps for the trap. and then we can reuse the panels that were London bass traps from the kit. And you can see there now that we're up around the 30% mark. So it's not a 100% guide as to what you should do. It's just giving you a ballpark of where you should be. So I'll just get rid of that screen and go to the Room Designer. So this is their Room Designer. And you can see here, we can quite quickly create a room. Just get my notes here because I've pre-done this so that it will be easier to do without looking around too much. So we've created our room there, and then we can place some, let's say we'll put a door. And put some window in. And then we can switch to a 3D view, and you can see here that we've got the basics of our room. So this is a really good tool for this kind of thing because it's so easy to use. I'm not a designer, but I've tried to do this in SketchUp and those kind of programs before, and this just takes me forever. But with this application, it just makes it so much easier, and anybody can do it. So we can just add some more furniture here. I'm not going to be too picky with the positioning because otherwise we'll be sitting here forever watching me move stuff around. So you can see they've got all sorts of things here. So you can create quite a professional looking drawing in the end. Somehow the speakers have ended up facing each other. Still doesn't. And we can put some furniture in as well, and like I don't know why, but they've called this a love seat. So I think we've got enough there to make the basic little studio in here for a home studio in your spare bedroom. Just one window and a door. Obviously, in your situation, you might have a different layout. So now we can start applying some acoustic treatment here. And we'll start with that London 16 kit. And we'll just place these . So at the back of the room here, we're just putting some scatter blocks in. Apologies, I messed that up. And the purpose of these scatter blocks is to control the Flutter echo. And this is the sound that would bounce between the back wall and the front wall multiple times. And Primacoustic is enabling a feature to create this grid effect without having to do it like this, so it will be quicker. So, see how neat I got that. I missed a couple. So, I'll just zoom back out. So essentially what we're doing here is when the sound comes from the speakers, hits the back wall, we're going to absorb some of that frequency or some of that energy and stop it from getting back to the front wall and then back again. And adding some control panels up the front here will assist with that as well. And then the bass traps as well. Oh, I've got enough space there for that. No. Oh yes, there we go. Bass trap there. You can see here there's not enough room to put that bass trap in the corner, so we'll just put this panel here for the moment. And then the other control columns, these would be strategically placed around the room. And what we're wanting to do is place them so that they're going to have the best effect in terms of absorbing the frequencies from the direct sound from the speakers. So naturally, the closer you are to the speakers and the listening position, the panels will be closer together. And then as you extend out through the room, they'll be further apart. I think I might have used too many there. So I could probably space those out a little bit more. So you can see there that we've placed all of the panels from the London 16 room kit in here, and it could be a little bit neater, but you'd be seeing there while watching me change them all, so I'll just leave it the way it is for the moment. So essentially what you've got, you have the bass traps, which are helping you with the lower frequencies, but they're also adding to the room absorption as well. So as well as helping with the bass frequencies, they're also helping with any reverberation that's going around the room. These control panels and the scatter blocks are helping with the flutter echo and the energy from around the speaker. And then these panels along the sides, close to the listening position, these are the ones that are absorbing the direct reflections from the speakers. And then as you go through the rest of the room, you're adding more absorption. Now, if you wanted to do a little bit more with this room, like we did in the room calculator, we can add some additional components in here, in particular the bass trap and the ceiling above that listening position. So what we will do here, we'll just reuse these larger panels up close to the listening position. So I'll just move this around a bit. And then we can add the max traps. Oops. Now, again, you won't be able to fit a max trap into this corner. So here we could use the full trap instead. So now you can see there, we've added the bass traps into the corners of the room. And we've repurposed what was the London bass traps. We've repurposed those up the front of the room here to provide extra absorption. And then we can use the control panels spread strategically throughout the room. And then finally, we can add the Stratus panels. So we would put these together in a grid. Messed up the centering of that. Yeah, that's back to front. So there, again, you want to absorb the sound that's coming from the speaker directly up into the ceiling and preventing that reflection from coming back down to the listening position. So I might just stop there. Does anyone have any question?
Yes, there's a question from Nick.
Hi, Nick.
Is that calculator spreadsheet publicly available?
Yes, we can put it with the downloads for your meeting notes if you like.
Oh, good. And the room designer. So that's the calculator.
Yeah. So the room designer is just a link to their website. So
right.
Anybody can use the room designer. The room calculator is not available on their website, but we can make it available in your meeting notes.
Oh, thanks very much. That's good.
So if there aren't any more questions on that, what we can do as well, this arrangement actually is quite suitable for a home theatre system as well. So I might just remove the ceiling treatment because in most home theatres they put one of those Starry Night ceilings in, so that kind of takes out the ability to use any acoustic treatment up there. So you can see here that you can quite easily use it for a home theatre system as well.
And Matt Pallo wants to know, how do you tell what it will sound like?
It will sound a lot better.
You build it to see.
He wants to know if you can do any optimization, I think.
Yeah, so I mean, of course, if you have access to like a sound level meter where you can make measurements like RT60 measurements that kind of thing, then of course, yes, you could use that to determine how much more accurately how much treatment is required in the room, because then you can then get use the calculation with the noise reduction coefficient. You can work out what effect it will have on the reverb time in the room.
Good.
But that's something we normally refer off to acoustic consultants. But there are plenty of people out there that will have a go at it themselves, especially if they've got a good sound level meter of their own.
Is that okay, Paolo?
Yes, no, that's fine. Look, I just thought there was some, even if it was, not overly analytical, it was, even if it was subjective, if there was a way to get some feedback. So you're moving, you're placing your panels, you're moving them around, and if you could run some rudimentary analysis, that would be wonderful, as a starting point. And then you move your panels around again, and you see whether there was, that half a meter or whatever you've done has given you an improvement, So that's all that's the basis of my question, because you can get it looking really nice. And I appreciate the theory, Matt, behind, how you're putting the panels closer to the source, and you're thinking about it in terms of common sense, in terms of where the reflection going, where the source is, where the listener is. I just was thinking, gee, wouldn't it be good if it could do that as well?
Yeah, well, just on that, they actually are always adding features to this, and I know that the next thing they're doing is they're combining that information from the spreadsheet directly into the room planner, so that will save having to use that spreadsheet, because it's not the easiest thing in the world to use. And then, of course, moving on from that into things like what we were talking about, where you can actually say, okay, my speaker's here and my listening position's here, and if I move this panel around, this is the effect that it's going to have on the room. So, that's another feature for them to have in the future. I'll definitely suggest that to them.
Okay, great. Thank you very much, Matt.
Is it worth spacing the panels so that they're not directly opposite each other, so that they're staggered? Is there any benefit in that?
Yes, that can be quite helpful in certain situations, especially if you don't want to use a lot of treatment in the room. There may be some situations where, for some reason, just as an example, I can think of a few weeks ago, we were looking at a boardroom where they needed to reduce the reverberation time in the room because they were having problems with their video conferencing. And they had a whole wall of glass framed images of work that they had done in the past. And of course, that meant that whole wall wasn't available for acoustic treatment. So what we ended up doing was putting half of the photos on one side of the wall and staggering the treatment exactly as you just described, where you have a panel on one side, a photograph on the other, and then a panel and a photograph on the other, immediately opposite. So yes, that using that kind of scenario can be quite helpful as well.
Okay, there was a comment there from Richard relating to we have reasonably good rooms. I wish we did, but probably wanted to add some panels to the ceiling. Did you want to comment on that, Richard? Richard's gone.
Yeah, got it. Yeah, I would think most of the people, at least in the ASSG, already have, pretty decent rooms to work with. We got a lot of acoustic treatment. We've been in this business a long time, and know a lot of people that are highly knowledgeable and have assisted us. But there might be, for us, most of us, I think, all the white-haired guys, we might we don't do stuff from scratch that much now. It's more like a matter of adding a few panels here and there. In our case, probably on the ceiling. because we usually have sort of decorative rugs and other base traps and stuff on the walls already.
We'll give it a go and see how it comes out. Report back.
Yeah, I'm just saying, if, it'd be, I think a catalog of everything to all the attendees would be useful, because it's the individual items to just refine the rooms we work in. And we usually got more than one place we work as well. So it still may add up to a significant quantity, but it's just be distributed, shall I say.
Okay. Matt.
Yes, I'm pretty much done with the presentation. So,
well, now's the chance for your grand questions. You're all stunned into silence.
Perhaps if I could make a comment on the baffles. Baffles work by being a quarter wave absorber. So if you've got a standing wave between the ceiling and the floor,
yes,
the length of the baffle is 1/4 wave of the frequency that you want to trap.
Yep.
So if you have different frequencies over that range from 0 to 150, you arrange the different lengths. So the maximum at the middle of the quarter wave is the bottom of the trap.
Yep.
Maximum velocity.
Yeah.
Minimum pressure.
Yes.
Good, thanks.
Matt, Graham Haynes here. You make no mention of any floor treatment there. So what is this floor surface of your little designed room that you put up? What do you expect the floor to be? What did you treat the floor with, and should it be treated?
Obviously, in a critical listening environment, you probably wouldn't want a hard floor surface. Primacoustic doesn't really do anything with floor treatment because they don't do carpet, basically. But certainly, yes, the floor does have an effect. One thing we've noticed is that in a lot of corporate situations, you have those carpet tiles, and they're effectively very low profile pile with a rubber backing on them, so there's virtually no effect on the acoustics from those kind of products. So in a lot of cases, the floor is something that you just have to live with, and you're controlling the reverberations on the available wall space that you have.
Okay, thank you.
I've got a question, Matt. David Hudson.
Yeah.
Hi. Regards to my former Amber colleagues. Just a question about delivery lead time and, stock ex-Warri wood versus indent from Vancouver and that kind of thing. Just the practical aspects of delivery.
At the moment, it's somewhat difficult because there's been a lot of disruption to the supply chain at the moment, both in terms of raw material and from just from being able to ship things around the world. So you do get some delays like that. But before COVID occurred, we were usually able to get something into the country that was a special order item within about 6 to 8 weeks.
Right.
And since COVID, that has extended out to 3 to 4 months sometimes. So
yeah, there's a real container shortage and issue, and logistics are a mess, I understand.
Yeah,
but the popular. Go ahead. Go on. I was just thinking the popular products maybe would be the ones that might be held in higher levels than the custom stuff.
Yes, so we try to keep all of the London kits in good stock.
Right.
Because they're the most commonly sold item because of their simplicity in the way they work, and it's all the other items that sort of add on to them later if people feel the need to do that. So we try to keep the London kits in stock as much as possible, and then the other items as they can go.
Great, thank you.
Matt, have you seen a spike in demand for acoustic treatment since COVID, or is it dropped or flattered?
Yeah. We've sold a lot more kits than we have in the past. In probably about 2 to 3 months into the sort of the pandemic starting, we sold a lot more of the kits, and I think part of it was due to people working at home and doing video conferencing and those kinds of things, and discovering that the sound in their rooms wasn't that great. But I think also there were some people that were doing things like home theatres and small recording studios and things like that that probably added to that. But I think a lot of people had spare cash that still had a job, and that's one thing they can spend their money on instead of a holiday that no one can have.
Gerard Mack wanted to ask about treatment for stereo music listening and surround audio post-mixing in the same room.
Mm-hmm.
Where's Gerard?
Here I am. Can you hear me?
Hey, Gerard.
Yeah, Andrew, yeah.
Yeah, just a general question. So for example, one of those London kits do for a surround room, would it make any difference at all? You're just treating the room rather than the actual mixing configuration. That's what the...
Yeah, so you would be switching between doing stereo work and surround work, is that right?
Yeah.
Yeah. And in the stereo configuration, would the main left and right speakers be in the same position, or would you move them?
I have, yes, they are, and I've also got some other reference monitors, which are slightly different spacing.
Yeah. So I guess in that situation, you would you'd have to be selective about where you were placing the panels based on those two room environments and try and come up with some compromises. You might find that in some cases the positioning of the panel might actually be the same for each of the speakers that are in the room. Yeah, certainly you should be able to still get a pretty good result from it. If you wanted to get really fancy, you could put the panels on some kind of movable frame, so you could move them around for your two different scenarios that you're listening for.
I see a few people there checking out their ceilings while you're talking. So prospects there, I think.
Yeah.
Okay.
Ceiling is actually a good thing to treat for boardrooms, because you imagine you're sitting around a boardroom table, people are speaking and their voice is reflecting off the table into the ceiling. So if you can actually absorb the sound in the ceiling before it starts reverberating around the room, you've solved a lot of the problem.
Good. Other questions? Well, it's that time of the night. I wanted to, on behalf of the group, I wanted to thank you, Matt, very much for preparing and presenting tonight. Very interesting and a lot of interest from what I can gauge. So thank you very much. Everybody unmute and a bit of applause for Matt.
And Matt, you had a tough audience. So
well done.
Especially with Richard.
Well done, yeah.